Okay, so first lesson we did was limits. We talked about what a limit was, right? As it's approaching a number. So as x is approaching some value, right? What is the y value? What is the y value approaching, right? So in order for a limit to exist, the left-sided limit coming from the left side has to equal the same y value coming from the right side, right? If there's a disconnect, there's no limit, right? But if these two meet at a y value, that's the limit, right? That's the limit. So that's the idea. So today we're going to do it the other two ways. There's three ways to find a limit. Graphically, which you guys just did looking at a graph. That's probably the easiest way. Using a table. Table, it's rare that they ask you to use a table. But I have seen it in the past, so I want to show you how to do it. It's pretty easy. It's pretty easy like graphs, because tables are pretty much graphs. And then the last way, the most common way, is what we call analytically or algebraically. Okay? So let's do the table one first, because that one's the one that's pretty easy. So I filled out my table. Your table's not filled out, but I filled it out just because I didn't want to sit here plugging in values, so I just did it before class. So example number one. It says use your calculator to generate the graph. We don't have to look at the graph. Don't worry about that. But what I did do was fill out a table, right? So this is how I got the numbers. I plugged in 1.5 into f of x. So I plugged it in here and I plugged it in here. When I did that, I got 3.5. And then I plugged 1.75 into here for x, and I got 3.75. And then I did it for the rest. Okay? Because if you did it by hand, it'd take you forever. And even on the calculator, it takes a while because you got to plug in each one. So I just did it for you guys. Okay? So they're all black because they give you numbers, right? 3.5, 3.75, 3.9, 3.99, 3.999, 4, 4.01, 4.1, 4.25, 4.5. What 2 is the only one that doesn't have a value? Why doesn't 2 have a value? Why is it undefined? Why does it make sense that 2 would be undefined? Close, you're getting there. What is special about 2 and f of x that would give me no answer? What would make it 0? Exactly. If you plug in 2 for x, so if you plug in 2 for x, 0 on top is okay. You get 4 minus 4, right? Which is 0. But then you'd also get 0 on the bottom. 0 on the bottom is where we can't have 0. That makes the number undefined. 0 on top just means 0, right? 0 on top. So if you had 0 on top, that just means you get no pieces of the pizza, right? If I had 4 pieces of pizza, you get none, I get no pieces. That makes sense. But 0 on the bottom is the one where it causes issues. That's the one we're focused on. And that's why 2 is excluded. So if you see this part right here, this excluded part, it says you can use f of x, just don't plug in 2. That's what it's saying. Just don't use 2. Why not? Because 2 would give an undefined value. 2 would give an undefined value. If I plugged in 2, it's going to give me 0 on the bottom. Even if 0's on top, it won't matter. 0 on the bottom, no good. Okay. So B, it says complete the table. Well, we did that. Okay, so first thing, we noticed 2, right? First thing we noticed was 2. Right? 2, no value. So look at the left of 2. Look at over here. What do you notice? What's the thing that stands out most to you? What are the one or two things that stands out most to you?
The decimal points are the same.
They're pretty close together, right? They're pretty close together. Once they hit about 1.9, they're pretty much the same, right? They just keep repeating 9. Yeah, that's good. What else? What else do you notice about all of the...
F of x is always 2 more than x.
So yeah, so it looks like the relationship between x and y is just 2, right? We're just adding 2 to get from x to y. Good. What else? More specifically here. What's going on here as I do this? It's increasing and they're getting closer to 4, right? They're getting very, very close to 4. Are we getting to 4? No, right? How about going this way? They're getting really close to 4 in the opposite direction, right? So that's why we say the limit as x approaches 4 for f of x equals 4. But let me throw this at you. What if the question said this? What if the question said f of 4? That means plug it in, right? And what happens when we plug it in? Undefined. So that answer is not 4. This answer is undefined, right? Oh, sorry, not 4. 2, yeah. Sorry, change that to 2. Right? That means plug into. Well, when we plug into, we get undefined. Okay? So one of them is an answer, one of them is as it approaches. So that's why one exists and one doesn't. The answer doesn't exist, but the limit does exist because the y values are approaching 4 from both sides. Okay? So a table, the way you read a table is the same way you read a graph. You just look to see what it's approaching. Are the y values approaching the same y values as here? Okay? That's pretty much it. You rarely have to do that, but once in a while they'll throw a graph or a table at you and say, what is the limit? Okay? The way that most of the time you are going to find limits is what we call algebraically or analytically. So here are the rules. So let's say they don't give you a graph. Let's say they don't give you a table. Let's say they just give you an equation. That's what I mean. That's what I mean when I say algebraically. Okay? There are 4 ways to do it, and there might be more. I'm going to go over the more common ones. Okay? So steps for finding the limit algebraically. First, plug it in. Plug it in. If you plug it in and it gives you an answer, boom, you're done. Plug in the number. So as x approaches 4, if I can plug it in and get an answer, I'm done. Move on. Sometimes that doesn't work, though. Sometimes it gives you 0 on the bottom, right? Like the one we just did. So what can you do? Well, one thing you can do is factor, like you guys did on your summer assignment and summer assignment quiz. Factor, right? If it's a binomial, factor it. If it's a trinomial, factor it. If it's got 4 terms, factor it. Sometimes that helps. Common denominator. Sometimes common denominators help. If you want to get 2 fractions together, just like you guys did on your summer assignment and summer assignment quiz. Multiply by a conjugate. Conjugate is kind of rationalizing. It's a form of rationalizing. And then there might be others. Okay? If direct substitution yields a fraction with 0 in the denominator and something other than 0 on top, then you stop and you say the limit doesn't exist. So if we were to plug it in and I were to get a number on top and 0 on bottom, you're done. You just say the limit doesn't exist. If you get zero on top and 0 on bottom, that's when you use B, C, D, E, those guys. Okay? This way here, when a limit does not exist, it's just talking about what we talked about the other day. This right here. If the limit from the left doesn't approach the same y value as it does from the right, there is no limit. If all of these are equal, there is a limit. Okay, that's all it's saying, like what we talked about the other day. Okay, so here we go. Okay, so flip it over. The top is a little graphic. Yours isn't in color, but it's kind of a, might not help you today, but it'll help you later in this chapter. It's kind of a little outline how to find a limit. So it's saying, first thing you do is try to plug in the number. Plug it in. If you get a number, boom, that's your limit. If you get 0 over 0, we got to do one of those things, factoring, rationalizing, all of those things that we did, that you did on your summer assignment. If you get a non-zero on top and a 0 on bottom, the answer is D and E. Does not exist. Okay? So let's try one. Let's try example number 1A. There's no table. There's no graph. All they give us is a function. It's x squared over 3x plus 4. Okay? So rule 1 says plug it in. We're plugging in 2, right? We want to look for 2. So let's plug it in to see if we get an answer. If we get an answer, we're done. If we get a 0 on bottom, we'll handle it differently. So here we go. So I'm going to plug in. Oops. 2 on top. 2 on bottom. I get 4 on top. 6 plus 4 on bottom. 4/10. 2/5. Is 2/5 a real number? Like, can I put 2/5 in a calculator? Yeah, it's on the number line, right? So that's an actual answer. I'm done. You're done. Okay. B. B is a piecewise. It's got 2 pieces. It's got a piece on top and a piece on bottom. This is the first piece. Wait. This is the second piece. So it says, find the limit as x approaches 2 for f of x. F of x got 2 pieces. It's got more than one. It says, hey, if your x value is bigger than 2, if the number you're plugging in is bigger than 2, use the pink. If your number is 2 or smaller, use the green. Here's my question. Which one are we going to use? If we're going to plug in 2, which one do I use? Kind of a trick question. Well, definitely the second one, right? Definitely the second one. So let's plug it into the second one. The second one is the green. So plug in 2 to the green. So I get 4 minus 9, which is negative 5. Okay. Here's the thing. A limit exists if it has the same y value from the left side as it does the right side. So if it has a piecewise and you see it switches at 2, I go from green to pink at 2. I have to check both. Because the green tells me before 2. That's the negative side, right? That's the negative side. So I have to check it to the right of 2 as well, which is the pink one. If they match, that's the limit. If they don't match, does not exist. Okay, so that was the left side. So let me try coming in from the right side. I'm going to plug in the same value I plugged in before. So order of operation says you got to do exponents then multiply. So what do we get? 8. It also equals -5. Because 2 squared is 4 times 2 is 8. So 3 minus 8 is -5. I got -5 for both. That means coming from the left, coming from the right, they both approach the same y value. So therefore, the limit at 2 is -5. Okay? Okay, so let me throw a little bit of a wrench at you. What if the question said this? What if the question said that there? You don't have to write this down if you don't want, but I'm just kind of throwing something at you. Would I have to check both pink and green? No, you're right. Which one would I check? Which was the only one I'd plug into? Good. Why? You're right. You're absolutely right. 100%. Why just green?
Less than 2.
Because, right, there's no switching at 1. This only switches at 2. The reason I had to check both at 2 was because there was a switch here. It switched from green to pink at 2. There's no switching at 1. So all I got to do is check the green for that one. Okay? Good. Okay. All right. Let's check. Or let me do this. One more. What if I had this? What if I had that? What if that was the question here? Would I have to check both? No, you're right. Just the pink. Just the pink because I'm coming from the positive side, which is bigger than 2. Good. You guys got it. Sometimes I'll do that. Sometimes I'll throw one of those at you too. All right, let's see here. All right, so here we go. Now let's look at this. So we got the limit as a limit approaches -1. All right, so let's plug in -1. Everywhere I see an x, I'm going to plug in -1. That's my first thing. So 2 times -1 squared minus -1 minus 3 on top, -1 plus 1 on the bottom. Okay, I got to do my order of operations now. So this is going to be 2 plus 1 minus 3 over 0, which is 0 over 0. So I did exponents first. So -1 squared is 1 times 2 is 2. These guys change because I'm subtracting a negative. They change to a positive, and then I just add and subtract. So I got 0 over 0, right? So our rules say when we get 0 over 0 when we plug in, that means we have to do one of these guys here. We have to do one of these guys here. Factor, common denominator, multiply by conjugate. Which one are we going to do? Well, this guy, I got a trinomial on top and a binomial on bottom. So let's see if I can factor it using the rules. Okay. So the top is a trinomial. Bottom is a binomial. So for a trinomial, first of all, is there a GCF is there a GCF for the pink? No, besides one, no. So let's go to multiply a first term times the last term. I get -6. The middle term is -1. What are the two numbers that multiply to be -6 and add to be -1?
Did you get 2 plus 3?
Close. 2 and -3, yeah. Okay, so again, I use the box just because that's what I use, but if you use a different way, that's okay. So I put the first term, which is 2x squared up here. Put the last term, -3 here. And then the two things I got. So I got -3 and a +2, right? But they both need x's since they need to combine to make -x. That's where I get all the terms. And then I kind of do like reverse multiplication. What do I use to come up with these guys? So this guy is going to be x times x, right? I'm going to put a 2 up here since (2x times x makes 2x squared). 2x times 1 makes 2x. X times -3 makes -3x. -3 times +1 makes -3. So that's how I know I did it right, because it all multiplies correctly. So on top, that means it factors to 2x minus 3 and x plus 1. Hold on. Thanks. Okay. The bottom now, the green. That's a binomial. So for binomials, do we, or is it, there's our GCF? No, right? Besides 1, no. Is it difference of squares? Nope. So that means it's already factored. X plus 1. Now I have two binomials multiplied on top, one on bottom. Do any of them cancel out? Okay. So this guy actually is the limit as x approaches -1. Now it's just 2x minus 3, because the other two simplified to make, or just ones. Yeah. Now let me try plugging it. Let's see, it didn't work before, but I think I solved it now because there's no more denominator. There's no bottom. So this is -2 minus 3 equals -5. So the limit is -5. Okay. All right, let's look at letter D. So the limit as x approaches 0. First thing, always plug it in. Plug in 0. If you can do it in your head, plug it in your head. If you need to write it out, write it out. 2 times 0, 0 squared plus 4 times 0. Looks like we get 0 over 0. That means there's work left to be done. I see that the top is a monomial and the bottom is a binomial. So let me try to do what I did last time. Sometimes it works, sometimes it doesn't. You don't know until you try. The pink. is just 2 times x. I can't break down 2 because it's just 2 times 1. And x is just x. Bottom is a binomial. Does the green have a GCF? X, right? It does have a GCF of x. That leaves x plus 4. So the top I have 2 times x. The bottom I have a monomial of x times the binomial x plus 4. What cancels out? There you go. The x's cancel out, right? They become 1s. So now I have 2 by itself on top, x plus 4 on bottom. Let's try to plug in 0 now. Now I can. I get a number. It's 1/2. 1/2's a number. So by factoring, I was able to solve that. Okay. Okay, so before we go on to E, because E is another type, I want to do more like that we just did on C and D. So I'm going to give you some examples. So if you look at the last page, there should be some room towards the bottom. So we're going to skip ahead a little bit. We'll come back to letter E, but I want to skip ahead a little bit and give you some more practice on those guys. So okay. So the last one is F, so let's call this one G. All right, let's see here. The limit as x approaches 4 for x squared minus 5x plus 4 and x squared minus 16. Okay, so do that one. Okay, so first thing, plug in 4. See what happens. See what happens. If you get a number, a regular number, you're done. If you get something over 0, you're also done. The limit just doesn't exist. But if we get 0 over 0, we know that we have work left to do. So I plug in 4 everywhere there was an x, and I got 0 over 0. That means we have work left to be done. So the top is a trinomial, the bottom is a binomial. So I'm going to try to factor it like I've been doing. Okay, so try to factor the top, factor the bottom. Top is a trinomial, there's no GCF. So let me see. So you get 4 on top and negative 5 on bottom. So you're looking for the two numbers that multiply to be 4 and add to be negative 5. Negative 4, negative 1. So you get x squared positive 4 minus 4x minus 1x. So that means the top is going to factor to x minus 4 and x minus 1. Okay. Now the green. Well, the green is not a trinomial, it's a binomial. Doesn't have a GCF besides 1. Is a difference of squares. Yeah, right. It's x plus 4, x minus 4. Oops, not 1, 4. Now some things are going to cancel, or simplify, I should say. So now I don't have all of that on top. I have an x minus 1, and I have an x plus 4. Try plugging it into my new guy, my new function. Oops, not 3. 4 minus 1, 4 plus 4, I get 3 over 8. Okay. Let's see what time we got. 50. Okay. So let's try. Do we want to do that one now? Let's just do this one. Okay, so this guy here. What's different about this guy here than stuff we've seen in the past? It's got a square root. Okay? So E, let's go back to E. Well, that doesn't change what step 1 is. Step 1 is plug it in and see what we get. So if I plug in 3 everywhere I see an x, I get the square root of 4 minus 2 over 0. The square root of 4 is 2. 0 over 0, right? I got work left to be done. So anytime there's a root, okay, we're not going to factor. So if you have a root in your problem, don't try factoring because it's too hard to factor, okay? But we are going to do something called rationalize or multiply times a conjugate. When you see a root, most of the time we're going to rationalize or multiply times a conjugate. So my question is, looking at this guy here, which part of that is causing me issue? Which part of that is making me not like, which part of that was the issue with getting 0 over, or getting, not being finished with the problem? The green, the top, the numerator, or the denominator, the bottom? What is the issue here? Why couldn't I stop? Because I got 0 on the bottom. This is the reason why I can't be done. If I had anything else here, any other number than 0, I would be done with the problem. I'd be completely done. 0 on top means nothing. I could get 0 on top, but I can't get 0 on the bottom. So even though the green looks pretty ugly, and it is because it's got a root, it's not causing me issue. The pink on bottom is the one causing me the issue. So what I have to do is rationalize the bottom. So this is what you do. Rewrite the bottom. I'm going to multiply it by the conjugate of what's causing me the issue, the bottom. So the conjugate is the other term in difference of squares, right? In difference of squares, there's always a minus and there's always a plus. So in this case, it would be x plus 3. X plus 3. Okay. Okay, so let's see what we get. So the top, I'm not going to multiply right now because I really don't want to multiply. It's a lot of stuff. So let's see. So I get square root of x plus 1. Oops, no. Minus 2 times x plus 3. On bottom, I get x minus 3 over x plus 3. Could I cross out the x plus 3's? Actually, I could. I can. But why would I not want to do that? It's going to leave me in the same spot I started with, right? So some people are like, oh, yeah, I can do that. Yeah, but it's going to leave you the same spot you started with. Okay, so now let's try plug in 3 again. Let's try to plug in 3 again and see if we get anything different. If we don't, we'll go to plan B. But if we do, we're done. So let's see. On top, I get 3 plus 1 square root minus 2. And then 3 plus 3. On bottom, I get 3 minus 3 and 3 plus 3. So on top, looks familiar. So I'm going to get 0 times 6 and 0 times 6, which is 0 over 0, right? So that didn't help. So let's try doing so plan B is let's try doing the conjugate but of the top guy and see if that helps. So let's set it up this way. So I'm going to do the same thing, except now I'm going to find the conjugate of the green. What would be the conjugate of the green? Remember, x plus 3, x minus 3 were conjugates. So what would be the conjugate of the green? So the x plus 1 would stay, and it would be minus 2, yeah. Plus 2, yeah, you're right. The opposite, yeah. Okay. So the top, I have square root of x plus 1 minus 2, square root of x plus 1 plus 2. Bottom, I have x minus 3, square root of x plus 1 plus 2. Again, I don't want to cross out the second parts because then I would be back to where I started. So this is where you're going to do differently. The top is difference of squares, right? The top is difference of squares. The top is actually a binomial. The top has one term there, and then same thing here. It's difference of squares. So what I'm going to do here is I'm going to use difference of squares. Difference of squares happens when you have something squared minus something squared, right? That's when difference of squares happen, right? X squared minus 16, x squared minus 4, x squared minus 100, right? So I have x squared plus 1 times x squared plus 1. That's going to go in the first spot. That's the first term. And then the second term is 2. Bottom stays the same. So let's look at the top now. What happens when I square square root? Exactly. The square root just goes poof, right? So this guy here is just going to lose the square root and just become x plus 1. And what's 2 squared? Bottom, I haven't done anything with. We're almost done. The top, what can I do with the top? Top, I can combine some like terms. What do I get when I combine those 2 guys? X minus 3, right? And don't I have an x minus 3 on the bottom? Those guys can simplify now. So now the simplified version is as now plug in 3. Which equals 1/4 now. Now it took it extra long. It took extra long because we went a wrong path, right? We took a wrong path. It's okay. That's how you learn. Next time we won't do that. Next time we'll just go straight to the conjugate of the root. Okay? So we only got about 3 minutes left. So first thing I'm going to do tomorrow is we're going to go over another one like that. I have others like that. Okay? It won't take as long because you've seen one and because we know the correct path to solving those. Okay? So we're not done with the notes. We'll finish them tomorrow. Okay? The only homework that you have, is the assignment from yesterday. If you haven't submitted that, make sure you submit it by tomorrow. I usually give you 2 days to do assignments. So if I give you one on Thursday or Tuesday, it won't be due till Thursday by the end of the day. Okay, so we'll finish this tomorrow. I'm going to post these notes too, so if you didn't get a chance to write everything down, just